So for EKS, right here I have a data. We're creating an OIDC provider. Now I'm using a data source to get my cluster information. Okay? I want to use a data source, a data called AWS EKS cluster. This is the local name of my cluster, but the name of the cluster is demo. Okay, I'm using this data source because I now want to pass to get the TLS certificate. I'm going to use that URL. I'm going to use that same data source after it has returned that cluster. So I'm using that data source for my URL right now because that is the URL. This is the URL that is going to be used on my OIDC connector, right? But then this data source, we will create a service account for our cluster. The conditions is the principle that is going to assume is this federated provider, OpenID, but the value will be a service account, and we'll create a service account in the default namespace, and that service account will be called AWS test. Right? We'll create this service account called AWS test, but we want to create this OIDC provider so that it trusts this service account. So it is this service account that will use the permissions that will pass through this OIDC provider. So for our OIDC itself, we have this OpenID provider. Then again, for the URL, we are using that data source, right? That data source that we are passing right here. Assume role policy is the policy that we just saw right there, and we are creating a policy. And this policy, again, we are just passing the action is S3, get bucket location, S3, everything. We are passing this policy, right? And the resource, because these are resource based, the resource will be on all S3 buckets, everything S3, anything S3. So we are attaching that role, that IAM role policy. We are attaching it to the policy to our role. Okay. So these are the permissions that we will be giving to our pods. Our pods can only interact with this S3 bucket, right? S3. Now with that, I have my outputs. My output here, I'm just outputting the URL for the OIDC and the ARN for that particular provider, URL and ARN, and also the test policy, the ARN for my policy. I'm also outputting it on my provider here. That is the same thing. So now I'll go ahead, because I have my cluster running. I'll go ahead and provision this OIDC and the role. So what I'll do is I will right here, I'll CD to back and CD to full OIDC test. We want to test how permissions are going to work, or how permissions work in AWS. So now with this OIDC test, if I ls, I have my Terraform files right there. So I'm going to do Terraform init. I'll initialize it. My class already exists, right? Then I'll do Terraform validate, just to confirm my syntax. If it's good, then I'll do Terraform plan. So once it plans, the first thing it is going to use the data source to find my cluster, right? To find my cluster, it reads the cluster because it needs to return some information about that cluster. So it is going to return that OIDC URL, right? It's going to now return, open that, or rather create that open connect provider, and these are the policies. That's the role, and that's the attachment, and it's going to return for us this policy and OIDC URL. So I'm going to apply to create that. So all that is created. It has created the OIDC provider, and it has basically created everything. Now, what we'll now do is I'm now going to create a pod, right? We want to create a pod with a certain service account. So before I do that, let me log into my cluster. I'll do AWS EKS -- region. Region is US East 1, then update --kube config. I want to update the kube config for the cluster called demo, right? Cluster called demo. So once I do that, I've now updated it. When I do kubectl get nodes, then I should be able to get 2 of my nodes that are ready, right? 2 of the nodes that are ready. Now, because now I have my nodes ready, I now need to deploy a pod and create a service account. So how do we do that? So inside of here, I have this manifest. I have a pod. Now this pod, the API version is v1. Kind is pod, metadata, just AWS CLI. The namespace is default. Okay. When you come to the spec right here, creating a container. This is a container just called AWS CLI. The image that I'm using is Amazon CLI, and I'm passing the command, right? Command with this argument. So while true, do sleep and done. So this will just keep going because it will always be true. So while true, do sleep 30 and done, and it will keep repeating that. So this is just a pod that will just run consistently, right? This pod can tolerate our worker nodes, because on our worker nodes we had put a taint on it, a taint with an effect of no schedule. I think when we were creating our worker nodes, when you look at your code, it has a taint, right? But now the important thing is when you're creating pods, you will use a service account name in the spec. You will pass a service account name where this particular pod is going to use. Now, if I do kubectl get service account, right? Service account, you'll see that there is always what we call a default service account created in every namespace. So if you create a pod without specifying a service account, it will always use this default service account. If I do kubectl like get or describe service account default, right? You'll see that this is a service account that is in the default. It's called default. It's in the default namespace. It doesn't have any labels, no annotations, image, post. Everything is none. It doesn't have any token or event. So this is the service account that is by default always attached to a pod. So for example, if I do kubectl run, I want to run an Nginx pod, right? An Nginx pod with the image /image equals to Nginx, right? Nginx. If I run that and I create that pod and I go do kubectl describe pod Nginx. When I describe the pod right here, and I look at the namespace is default, right? Annotation is none. Container ID, image, default pod, restart environment. These are mounts. We have a mount here, mounting a secret with a service account, right? With a secret to a service account. But if I if I look at the secret volumes, the node configuration volume pod. If you look at this this volume mounts, they're always mounting a certain service account, which is the default. Okay, let me see, where is it? Annotation is none, labels is none, namespace is none. Okay, let me do this. Let me do this. Oh, okay. Let me do this. Let me do kubectl get pod Nginx dash o IAM, and let me direct it to pod so let me catch pod.yaml. So again, now this is the pod manifest. This is the pod manifest that was created automatically for me by Kubernetes, by Kubernetes. And last time I told you guys about mutating access controls. So you see that we have a lot of other information that was added to my pod spec that I didn't. So before the pod was admitted, it was mutated, right? There was an admission control. Now, when you look at this pod spec, there are a lot of other things that were added, but the service account that this pod is using is default. The service account name is default, right? It is default. So this pod, if you don't pass a service account, it will always use the default service account that is in every namespace. Okay, but now that default service account, as we saw, it didn't have any tokens or permission. So there's always a default service account, and the mount part, as we saw, it is mounted as a secret. You can find the secret, which is a token at that particular path, right? At that particular path. So for us now to do this, we want to create a pod, but create a service account that has some permissions, right? Has some permissions. So what we will do first, we will go ahead and create our service account. So our service account, we will create our service account. Our service account, and let's first comment this out. We'll just create a service account, and our service account is called AWS test in the default namespace. Okay, so let's go ahead and cd into manifest, right? And I will do kubectl create dash f. It is called svc, right? I've created now a service account. So if I do kubectl get service account, now I have these two service accounts, right? I have the default, but I've also created one called AWS test. That's a service account in the default namespace. Now let me go ahead and create my pod. This is the pod that I'm creating, and this pod, I'm specifying that it's using this service account. So this pod, I will do kubectl create, and I want to create AWS test, right? My pod has been created. If I do kubectl get pods, I have this particular pod. The container is still creating. Now my container is running. Okay, my container is running, and it is using a default. It is using an AWS test service account, right? How can I check that? I can do kubectl get pod. The pod is called AWS CLI. Then I can just check the YAML file. Right? If I output that, this pod again was mutated admission control. So you see a lot of other things have been added. But when you look at the service account that is now using is AWS test. Service account name is AWS test. Now let me try and exec into this pod, right? Let me try and exec into this particular pod. And once I exec into this particular pod, let me see if I can list buckets. Remember, it is using a certain service account. So let me see if I can list buckets. And the service account that we created was just this, right? So for this, I'm gonna do kubectl, and I'm gonna exec, right? I'm gonna exec into the pod. What is the pod? The pod is AWS CLI, right? And while I'm inside of the pod, I want to run some commands. I want to run AWS S3. I want to call the S3 API, right? And I just want to say list buckets, right? List buckets. So I'm now executing. I'm inside of that pod. But while I'm inside of that pod, can I actually query an API inside of AWS? So if I do that, it is going to tell me I have an error. Access denied when calling list bucket operation. Access denied and the command is terminated, right? So I go inside of the bucket, inside of the pod. I exec inside of my pod that is running. while inside of the pod, I run a command. I run a command, right? So if I exec inside of that particular pod and I say, who am I? Who am I? Right? I see that the user that is running commands inside of that pod is a user called root, right? So I can run commands, I can exec inside of that pod, and I can run commands inside of that pod. If I if I exec inside of the pod and I run ls, right? Ls basically it's not returning anything there for me, but I can do AWS S3 ls, right? It is going to tell me that list bucket operation access denied. Now it is using a service account. Now what will make that service account now operational? It is what we call annotations. So this is where annotations come into play. So now for my service account, I need to add an annotation on that particular service account, right? And the annotation is that I'm allowing this EKS, Amazon EKS, the role and that is going to be using this service account is this particular ARN, right? It is a role called test OIDC, right? Role called test OIDC. So if I look at my role, it is a role called test OIDC. This is the role. This is the role that I created, and this role has these permissions. Okay, has this particular permission. So this role, test OIDC, with this permission, I'm allowing it by annotating my service account that the role that is going, the permission that are going to be used by this service account is this role. Okay, test OIDC. Now, this is the role that will give this service account permission. And how is this role being fetched from IAM? It is using that federated provider. It is using this provider, right? Service account default. In the default namespace, it is called AWS test, right? So I'll go ahead and again reapply this service, right? So I'll do kubectl apply -f, then I'll do svc.yaml. So once I do that, it is going to reconfigure, right? Reconfigure my service account configured. So it has reconfigured my service account. So now my service account includes an annotation. If I do kubectl get or describe service account, which is called AWS test, right? Now we see that my service account, it now has an annotation. This annotation, it is pointing to a role ARN, and this is the role that has the permission. So basically this pod, because it's using this service account, it is going to get permissions from this particular role. Okay. So now with that, let me exec back into my pod. And now can I list bucket? If I exec into the pod, it's telling me an error list bucket occurred. So with that, let's list buckets, an error. We call it list bucket access denied, command terminated, CLI. Okay, it has the annotation. Then what permission does it have? It has S3 splat get bucket on that and all resources. That is my action. S3 splat S3 get bucket location, which is what list all buckets, get bucket location. Okay, list all my buckets. Unless okay, let me see. Let me add one permission here. That doesn't make sense. Let me add S3 list all my buckets. Let me see what other permission we can add. This list all my buckets. List all my buckets. That's the right permission. It's correct OIDC. Correct OIDC. And then is the correct role. Test. Service account is AWS test, which is AWS test, and that is the annotation. The role ARN. Let me go to AWS and make sure that is the correct ARN that I passed. I am. So I need to look at the role. The role was called test OIDC. And the role is that ARN for 167 role test OIDC. And that's the correct role. So let me cd back first. Let me do Terraform apply. Yes, so I've done that. Let me keep CTL. Let me see it into manifests. Manifest, make it, yeah. Apply, F. As we see, I'm gonna change to apply F, AWS. Okay, so the pod has been reconfigured. Yeah, I needed to reconfigure it because the pod CLI it should now have an annotation. So if I do keep ctr get pod AWS CLI and I do -OYAML, I have a service account, latest law supply scheduler. It now has my annotation here, and the annotation in this in the pod, it now contains an annotation of a sound account name, of a service account name, a service account name, donation. Let's see. All right, so let's see if that is going to work. So let me exec into the pod and let me list buckets. An error occurred. An error occurred existing. I've been calling list buckets operation. Okay. An error occurred. Now I've passed everything correctly with the annotations, but it's still giving me an error. Where is the error coming from? I'm looking at my manifest here. So let me just, yeah, let's, what is it going? So right now, whatever we're doing, it can double up. It's both infrastructure, engineering, and platform. So platform just means that we're using our Kubernetes platform to run our application or to deploy our resources. So this is platform engineering, right? So you can use both infrastructure and platform. So we've created our infrastructure. Now we're trying to use it. But right now what we're doing again is still infrastructure, because we are trying to provision our OIDC provider to make sure that our OIDC provider works, right? To make sure that our OIDC provider works, so that our pods can have access to AWS, to query AWS services. So I'll go ahead and again get my service account just to see if that will make a difference. I'll create a service account. No, I just create -F, and then SVC. Service account created. This service account has an annotation, right? If I describe it, I'll keep CTR, get service account, AWS test -O YAML. If I try to get it, then I'm gonna get that one. It has that annotation inside of my service account, right? It has a annotation. Then I'm gonna go ahead and create a pod. So I'll create my pod. Kubectl create -F, and the pod is AWS. At AWS, my pod has been created. And so if I do kubectl get pods, my AWS CLI pod is running. If I describe it, or if I do kubectl get pods, AWS CLI -O YAML, then I need to see that this particular image, that particular image has been pulled. Okay, that particular image has been pulled. Service account token expiration is that, token part is that is service account token. I will see that the service account is that.
Yeah.
Hey,
Gabriel,
can you please mute yourself?
I'm sorry.
All right, so we have that. And get to environment. It has this role IRN, which is that is the value of the role ARN that is supposed to be using test OIDC. These are the arguments, right? The arguments in that particular data. So everything seems to be passing correctly. So let's try and see if we can list buckets or read buckets. I can do keep CTR exec. I want to exec into AWS CLI pod, and while in the pod, we use this 2-. I want to run the command. Okay, so who am I? I can exec and root. So I'm inside there. Can I run the command AWS S3 ls? So while I'm in there, now you see I can list my buckets, right? I can go inside of the pod and I can list my buckets. Like, where is this permission coming from? This permission is coming from the role, right? It's coming from that particular role. Now, can I modify this permission just to test it out? Now I've used S3. Right now, the permission that it has, it is S3 full permission, right? S3 full permission list. So what about if I just did S3 get, but no list, S3 get bucket location. Let me check out S3 list. We check out S3 list, right? S3 list, I only have S3 get all actions, get bucket location. So this is redundant. So I'm just gonna give it one action. For the pod, it can only do S3 get. So I will cd back, then I'll apply outro, approve, approve. So my policy only has S3 get, right? S3 get. So for that S3 get policy, I've just modified the policy in AWS. So can I exec back and do an S3 list? It's telling me an error occurred when calling list buckets, because in my role, I do not have permission to list buckets. I can only get. So can I do S3? I can go back here now and modify it and say S3 list. Now I've changing the permission to list all actions list. Then let me reapply it, change my permission. Now I only have S3 list. So now with that S3 list, can I list my buckets? Yes, I can list my buckets now from my pod, right? So I can exec inside of the pod and I can run S3. So my pod is able to communicate with other AWS services. It is able to communicate with my S3 buckets. But the permission that it is using a role that is being supplied by this OIDC provider. So now with that, I'm able to restrict pods and how they access AWS services. So how we do that is we use service accounts. And this is the default way of how EKS handles permissions, especially with pods. You will always use service accounts, right? Every pod uses a service account. There's always a default service account created in every namespace. So if you don't specify a service account, it is going to use the permission of the default service account. But that default service account does not have any tokens or any permission to interact outside of the cluster, to interact with any other AWS service. So if you have a pod that is collecting logs, and that log, it is able to put that log in an S3 bucket. Okay. So what you need to do is that you need to give that pod permission to be able to transfer those logs from the cluster and put them in the S3 bucket. How will you do that? You'll create a role. You'll use an OIDC provider, right? Like that, with a role with the permission of maybe S3 put, S3 get, and S3 put. And you'll create a service account that particular pod will use. That is the permission that you're giving that pod to interact with a specific S3 bucket to put your logs, because otherwise your pod will not be able to transfer those logs, because the default service account doesn't have permission outside of the cluster to interact with any AWS service. All right. So